In this video, we're going to look at standing waves. So this is the explanation of the demo that you saw in class. First, what are standing waves? Standing waves are waves created by interference patterns. So standing waves definition is a wave created by interference patterns. In a previous video, we talked about interference in terms of constructive and destructive. So we're going to see where there are areas of constructive interference and areas of destructive interference. Standing waves are always created on some sort of string or other material where one end is fixed. So in our example in class, we had the pulley, which was keeping the string stationary on one end. Another way you can do this is you can tie it to a wall in some way, or someone could hold one end. The fixed end will reflect back to the starting point. So it is a reflection. So an initial wave will travel through the string and then will reflect back. I know this looks like a lot, but when two waves of equal amplitude and wavelength pass each other in opposite directions, they will interfere with each other in a way that can result in a standing wave. So all this is saying is you have a wave and you have its reflection. If they're going equal and opposite, then they can interfere and create a standing wave. So let's look at some standing wave vocabulary. First, here is a standing wave. This should look a lot like the string you saw in class, where here we have a fixed point, so it's attached to the wall, and here is where we have our motion. This is our force that then creates the wave. The string is the wave, so the solid line is the wave. The dotted line is the reflection. So the wave is traveling to the right, and the reflection is traveling to the left. And what we see are areas of constructive interference and destructive interference. The constructive interference creates an increase in amplitude, and the destructive interference creates a decrease in amplitude, or a cancellation in terms of this spot. So the first one is a node. Nodes are areas that remain stationary. So this is where I could touch it and nothing happened to the wave because there was no amplitude. Destructive interference causes a cancellation. So areas that remain stationary. The way to remember this one, a node has no movement. So node, no. The other one is the antinode. The antinode is an area of constructive interference where we have the two waves' amplitudes adding together to create these large areas of amplitude. An antinode is an area of largest amplitude, and it's always between the nodes. So antinode has amplitude. They both start amplitude. Yeah. They both start with A. So amplitude, antinode. Now, one thing to note about the number of nodes and antinodes. There is always one more node than antinode. So in our picture here, I'll mark them in black since I've used every other color. We have 1, 2, 3 nodes and 1, 2 antinodes. Always one less antinode than nodes, or one more node than antinodes. So examples, let me erase that part. Strings of a guitar, and I'll make sure I put a link up to a very simple YouTube video of that. And of course pipes of a pipe organ. They will cause vibrations that then create a standing wave.